Hello, Mr. Mailer here, online math teacher. Welcome to my channel. Welcome back to my video series on two variable data, and in particular, today we're going to be looking at some properties of correlation. So if you find this video helpful, consider smashing the like button, subscribing, and let's go. So, correlation. It is the strength of the linear relationship between two values. We want to see how manipulating our data in some ways is going to affect it. So I'm going to use Microsoft Excel here because it's going to allow me to quickly analyze some of this data. So the first thing I'm interested in, if I just know the correlation value for my first data set. And in another video, I show how you find this. So if I have the correlation variable value where I'm letting my height here be my explanatory variable and my weights be my response variable, I see that I'm going to get a correlation of about 0.889. So I get this here. But what would happen if you switched roles? So if you made weight your explanatory variable and height your response variable. So you still have a fairly linear looking scatter plot. So I've changed this on another page where I've reversed them. But now we want to see what happens. So if I again try to find the correlation for my data here. So I start out with my correl function. But now weight is going to be my explanatory variable and height is going to be my response. I get the same value, 0.889 for weight as explanatory, height as response. That is the same as when I add height as my explanatory and weight as my response. This is because correlation is a strength. It measures the strength of the linear relationship. Regardless of which variable you choose to be your explanatory variable or your response, it's going to give you the same linear relationship. You're not changing anything about how the variables relate. The equation of your least squared regression line might be different, but the correlation, the strength of this relationship is going to remain the same. So correlation will not change when you swap explanatory and response variables. Another nice thing that we have is the following. So we want to know what happens when I alter my data sets. Will correlation become stronger or weaker? So let's say we accidentally forget a number here. So let's say we have our value of this person who is 64 inches tall, is 130 pounds. What happens if we left off that last zero and said they were 13 pounds? This is going to create a fairly substantial outlier that does not contribute to the trend of our linear data. So if I get rid of that, you're going to see, I now have a point that does not follow the linear trend, and my correlation decreased. So when points do not follow linear trends, you will see that correlation will decrease. So if I change a value so it doesn't follow my trend, your correlation will decrease. Now on the other hand, I'm going to bring this back to 130 so it looks nice. What happens if I were to, instead of changing a point so it didn't follow the linear trend, what happens if I extended my linear trend? So what happens if I take somebody, say, that is, maybe I take my 67-inch person. I'm now going to make this person be about 85 inches. So they're going to be playing in the NBA at some point. And I proportionally scale up their weight. Maybe let's put this at around 250. Does that look like it's good? Even a little more. So now this looks like it continues and extends my linear trend beyond where most of my data is. So when you add a point to your data set or edit a point, so it extends the range of values you see this linear trend holding up for, you're going to see that your correlation will increase. So my correlation increased from about 0.8 something into the 0.92. So if you add a value that continues and extends your linear trend, your correlation will strengthen. It will either get closer to +1 or get close to -1, depending on if it is a positive or negative relationship. The one last thing I wanted to talk about as far as properties go is what happens when you convert. What happens when you do conversions? So what happens if I want to have all my new heights in centimeters? So I'm going to multiply every one of my heights by 2.54. So I'm going to take my 70 inches in the A2 cell, and I'm going to multiply that by 2.54 centimeters. I'm going to hit equals, and I can drag down, and Excel's going to know, oh, I want to go to A3 next, A4, multiply by A5, and so on. So I can quickly scale all my data here. Now when I go to calculate my correlation, I'm going to start with my correlation. I'm going to pick my heights in centimeters now instead of inches. I'm still going to keep my weights in pounds, so I'll select those as my second array, hit enter, and I see I have the same correlation as before. So another nice property of correlation is when you do unit conversions, heights to in inches, centimeters, weights and pounds to kilograms, you name it, correlation is not going to change. It's not going to affect the strength of the linear relationship just because you've changed the units of measurement. So in summary, you can swap the explanatory and response variable, and that will not change your correlation. It will be exactly the same. If you add a data point that does not follow your linear trend, it will weaken your correlation. So your correlation will get closer to 0. If you add a data point that extends a linear trend, it will strengthen your correlation. So your correlation value will either get closer to +1 or -1, depending on the direction of your linear trend. And if you do simple unit conversions, height, say inches, centimeters, weights, pounds to kilograms, and temperatures, Fahrenheit to Celsius or Kelvin, if you're doing these nice linear transformations of your data, you will not see a change in your correlation. So I hope you found this video helpful. If you did, smash that like button, subscribe, and have an awesome day.